Okay, so go to the handouts. We need to move forward. That's all we're going to talk about regarding multiple linear regression or regression at all for that matter. I reminded you that this course deals with three topics: ANOVA, regression, and where we're going now. So we're quote unquote finished with regression. I don't know if you ever really finished with it per se. I think I told you guys when I was in graduate school in the DC area, one of the courses that I took was just called ANOVA. So just imagine a whole course, 15 weeks of ANOVA. Another course I took for 15 weeks was called regression. So just imagine just a whole course dealing with regression. And then another course I took 15 weeks was called time series. So we're getting a little bit of each topic, but this is the last topic we're going to deal with all semester long. So we're going to sort of go through. I don't know how, we're not going to really need the board that much right now. That's why I turned off the other camera. But if it gets to a point where we need to use the board, I may have to kind of adjust some of this. So try to figure out a way of how you can fill in your table or the handouts as we go along. I'm going to be typing on my PDF as we go along, so you can sort of do what I do, or if you printed it out and you want to write on yours, then that's fine too. We'll see how this works.
Professor, how do you get it to be able to write on it? Because when I download it, it's just like a picture. Like it's
Yeah,
not getting down for
yeah,
me.
it's just a PDF.
Yeah.
Yeah, so there's a website I went to called smallpdf.com, and I just had to Google it. And if you go to smallpdf.com, it'll put it on like a website. It'll allow you to kind of type on it as you sort of go along. If you have an account also with Adobe Acrobat, you can go to like edit there, and it'll allow you to kind of type on it. I've seen some students, they've turned some stuff in on PDFs. They were able to find a way to write on it. The foolproof way is just to print it out and just write on it by hand. But if you go to I don't know if you can see my website up here, smallpdf.com. It'll allow you to upload the document, the PDF, and then it'll let you write on it.
Okay, yeah, I don't have a printer, so I'm gonna go to that website.
Okay. All right. So we're going to go ahead and start, and you can just kind of catch up. All right. So as we know, we can investigate. We're going to see how this works. I hope this works. Regression as a tool for model building and prediction. Now I'm going to
I'm sorry. What was it again? Oh no, it's right there. My bad. I didn't see it.
Yeah, regression. All right. The limitation with regression is that although we may predict using the regression equation, we're only allowed to predict. I don't know if you guys remember this. We're only allowed to predict certain values within the range. So I'm going to have to type it, and then I'm going to have to adjust it and put it kind of sort of where it fits. And this goes back to checking to see if the values are in that certain range. We can't really extrapolate outside of that particular region. And this slide here is just more like kind of review. An essential aspect of managing any business is planning for the, let's say, future. Planning for the future. Okay. And it just says like when you're doing that, judgment is kind of necessarily to do that. But we're going to find out in math that translating this feeling of prediction into numbers, we're going to say numbers, can be pretty difficult. Can be pretty difficult. And again, I'm not going to expect you to know this stuff right here. This is just kind of leading into time series there. It's going to be difficult. All right. These challenges, we talk about predicting and kind of looking at certain data a certain way. We're going to use this notion called time series. So just write time in one of the blanks there. Time series. I'm going to find out a little bit more what this has to do with predicting and all this type of stuff. So, all right, essentially, these set of values, data values, will assist us in our quest to use the past to help inform our decisions for the future. Okay, but we're going to find out doing this method youth time series, we're going to do some predicting in the future. It's kind of sort of what we do with regression, but it's going to, when we see how the data is presented, you'll kind of see what that's going to mean. So again, the objective of such analyses is to provide good, we're going to say forecasts or predictions of future values of the time series. Again, I know none of this probably makes any sense right now. In your 220 class, they typically don't do time series. Yes.
Scroll up to the top really quick. I think I missed the second one.
There you go. And so you're going to find
Thank
out.
you so much.
So you're going to find out with time series, the data is going to present a little bit differently than regression, but we're going to see what that's going to have to do with anything. So, all right. So this is just the introductory slide. Now, when we talk about a time series, technically a time series is a set of observations of a variable measured at, we're going to say successive, SUCCESSIVE, successive points in time or over successive. So I'm going to put the same word there. I guess I could cut and paste it, but what does successive mean? Have you guys heard that term before? Technically, a time series is a set of observations or data measured at successive points in time or over successive periods of time. What does successive mean? I see the chat box. So. Successive. Have you guys heard that term before? Successive. It just means chronological. This, after this, after this, after this. So it has to do with the fact like one after the other, chronologically after the other. So we're going to find out with the time series, there are going to be 4 different components that we're going to have to feel comfortable with when we're looking at them. So the first component I'm going to call this. This is a little simple. This is pretty simple here. We're going to call it the trend component, and we're going to see what that means. So I'm going to give you data, and we're going to find out the data is going to look something like, oh, when it's all said and done, something like here, 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 and we're just going to end up like connecting the dots, right? In a regression, you notice we didn't really connect the dots. We just put like a regression line kind of to summarize the pattern of the dots. But here, like this could be January, February, March, April, May, June. This could be 2016, 2000, like years, 17, 18. But notice that they're successive, one right after the other. 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, right? But the thing that we're measuring has something to do with a notion of time, whether it's months, days, hours, like 4 o'clock, 5 o'clock. So that's what we're saying in time series, the measurements they're taking every hour, day, week, let's say month right here, month or year. It could be seconds, right? As long as you have the same consistency that you're measuring, it could be every quarter, right? So it's the notion that you have some notion of time there. Although there may be random fluctuations, let's say fluctuations here. This is probably better here too, because you don't have to worry about my chicken scratch in terms of handwriting. Let me put this here. Random fluctuations. The time series may still show gradual improvements to higher or lower values over time, right? And so you have this up and down kind of pattern, but when you talk about the trend component, you're trying to wonder what is the overall trend you can glean from what the picture looks as you look from left to right, all right? So this gradual shifting of the time series is referred to as the trend series. Okay, let's move this. All right, so as I said before, now this is just going to be an example down here. So that was month, then fluctuations, then trend. And this is just an example. I'm just going to write trend here again so you know what it is when you look at your notes. Trend, component. Now look at that diagram beneath there. So we have this time series model where you have all these dots. I don't know what it's representing. It just says time on the bottom. It could be January, February. Now that line going across, like this line right here, where it says upward trend, right? That's summarizing, and I know it's kind of confusing because when you look at a time series, typically this is all you see here, the dots and the connecting dots. But the reason they added this line here is it tells you what kind of overall trend the graph represents. So in a problem, if they ask you about trend, your answer will be, oh, I think that's an uptrend, or oh, I think that's a downward trend, or I don't see any trend at all. Pretty much like a horizontal kind of rendering, right? So that's all that's asking for trend, upward, downward, or none. Now, sometimes when you just stare at it, you can't really tell. So there's going to be some math that we're going to do at the end of the handouts, that the purpose of that math is to tell you what the trend is, kind of like putting a magnifying glass up to it. But at least you know in general what the trend component is asking, upward, downward, or none at all. All right, let's move on.
Professor, can you just go down for like 1 second? Because it takes a second to upload into the website. So like I just got done like the first page, and I think some people are still on the first page.
Are they saying that in the chat box?
Yes.
Who needs to go back to the first page? Speak quickly.
It was
Okay.
me, Professor, but they helped me out in the chat.
So here's the second page. Type quickly. I have to move on. Type quickly, or you can go back and look at the video. Or you might want to write down on a sheet of paper and then type it in there. That's the month fluctuations trend, and this is trend here. Okay, 1 more minute, and I have to move on. Okay, I'm gonna move on. That's component 1. The second component here, so the trend component just basically asking you, is it upward, downward, or none at all? Okay, you can fill these in later if you don't have them. The next component we need to look at is something called, yes, CYCLICAL. Oh, cyclical. And if you want, this is corresponding, all of this stuff is corresponding to, we're on chapter 12 now. So page 494. I think I put the pages in the chat box. So if I don't do a good job explaining this, you can always sort of go back and kind of reading up on this, but it tells you the different components and how to smooth. We're going to get to smoothing a technique. This is chapter 12. So if you want to follow along in the book, that's where we are, chapter 12. Now, what word do you see inside of there somewhere? Can you just look inside of there and tell me like what word is like in there somewhere?
Cycle.
Cycle. Very good. So you think of bicycle or a cycle, and anything that deals with maybe like repeating, right? Cycle. So I don't know if you guys in high school, if you took trigonometry, but there's something called the sine curve and the cosine curve. You guys remember that way back when? Probably doesn't bring up too many memories, but it looks something like this. Something like here. You got 0, pi over 2, 2 pi, all that stuff. Well, this goes to 0 to 2 pi, right? 360 degrees. Now notice here, and we're going to fill this out more in just a second. See see how this goes here, goes down here, and at some point, it's getting ready to repeat, right? So I'm just going to use another color. Oh, I don't know, something like this, something like that, right? So you get this kind of repeating behavior, cyclical behavior, right? So the black that you see is kind of similar to the red that you see. In trig, we don't call it a cycle, we call it a period. Right? We talk about something called period and amplitude. Amplitude is like how high this stuff goes, but period is like the repeating pattern, in a sense. So that's kind of what, the general idea behind the cyclical component. I'm going to say the cyclical component, so let's write cyclical again, depicts the up and down swings of movements through the series. In some years, the values are, let's say, higher than what we predicted. In other years, is low. In other words, if I were to draw like a time series, like from the trend line, some of the values would be above the trend line and some would be below the trend line. But the notion is it's going to have some notion of repeating, right? So if I were to look at website visits, if I do like a time series of how many people visit the websites in my company, you may notice this kind of repeating behavior that you get most of your views on Sunday. And it goes down, maybe fewer of your views on Friday, because maybe people are like in a movie or something, they're not looking at websites. And then when it starts over, it kind of repeats. It's like that kind of repeating behavior, right? So that's the notion of cyclical. In other words, many time series exhibit, say, alternating behavior within regular runs of observations. Now, okay, so from a business standpoint, you're not going to need to know this. This component is generally due to multi-year movements in the, I'm going to say, economy. Right? Now, when we look at this, I'm going to show you this in a second. Now, one of the confusing things about cyclical is that when we discuss it here, we're going to be kind of using a benchmark of like years, right? So I can say January, February, March, all the way to December. January, February, March, all the way to December. But that's just to give you a general notion of what a cycle means. But a cycle, as I mentioned before, as I alluded to before, a cycle could also be weekly, Sunday to Saturday, Sunday to Saturday, Sunday to Saturday. You just have to figure out where that general repeating behavior is and say, looks like the cycle in this problem is weekly. But here, when we discuss it, we're going to just use years as our base so you can kind of see the general idea behind what's going on. So regarding these components, just have a general idea of it. Now I'm going to say, and it's not going to become clear until we kind of look at a problem, but that's fine too. I'm going to say cyclical right here again. This is just an example of what we could see here. So essentially, it's going to be measured. We're going to say peak to peak or valley to valley. Peak to peak. In terms of the general explanation of it. Now, of course, when you give an actual data, you would be able to say, oh, weekly, the cyclical looks like it's repeating every week or every year. But this, in general, we're just saying, in general, you can locate it just by finding the different peaks and the different valleys, valley to valley or peak to peak. I want to try to explain what's down here. All right, so I don't know if you can see this. So this is some data regarding sales. Down here, according to this, is the time is years. I don't know what year it is, 1900, I don't know. But notice here, you see, I don't know if you can see here where it says one cycle. And notice the beginning of the cycle, see these dotted lines right here? Now, it goes down, it comes back up, and it's looking like it's getting ready to do the same thing again. Now, the reason cyclical may be a little different is because you're saying, no, 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 it's not going to repeat right there because this value right here is not equal to this value right here. Well, that's why we say in general, the pattern kind of repeats. It may be for these values over here, they may be a little bit raised up higher, I don't know, and these right here, but the general pattern seems to be decreasing and then increasing, increasing and then increasing. It's not that the values have to match per se. And look, see this right here? It looks like that has got finished increasing and that's ready to decrease again. Okay, so again, I know it's still general right now, but at least you understand in general what cyclical means, that there's like some kind of repeating behavior, that's occurring. Now again, we have to look at the data to see weekly, monthly, but just make sure you sort of keep that in tow. Okay, let's go to the third one. This is going to be, this seasonal component. And this is tricky too, because of course you hear the word season in it. But I want you to see if you can follow this logic. It's called seasonal. Even though on this page, we may get ready to write some seasons in terms of some of the answers, but the seasonal component depends on what you have identified as your cycle. If the cycle is weekly, let's imagine the cycle is Sunday to Sunday. If the cycle is weekly, then a discussion of the seasonal component tells me what's going on within that cycle. Yes? So let's just say the cyclical component, we said in terms of website visits, was Sunday to Sunday. Well, a discussion of seasonal pinpoints me like to the high value inside of there and the low value. Oh, on Sunday, it seems like I'm getting more views or the most viewers. And on Wednesday, it seems like I'm getting the less viewers to the website. But notice how my discussion of seasonal is restricted by what I have identified as my cyclical. So let's go ahead and fill these out, at least just from the standpoint of our cycle being a year. Okay. Let's say 1 year, where a trend and cyclical component are identified by analyzing multi-year movements. Any time series show a particular pattern over, let's say, 1 year periods. And the reason I'm putting 1 year right here is because according to what they discuss right here, it assumes that your cycle is over multi-year periods. So then a discussion of seasonal could very well be broken up into like 1 year periods there. Okay. The component of the time series that represents the variability in the data due to seasonal influences is called the seasonal component. Seasonal component. Now, in these blanks right here, we're going to end up writing seasons. But again, that's assuming that our cycle is over a year period, right? So then it perhaps makes sense to talk about within that one period, the different seasons. But I just want to make clear that when you talk about the cycle, once you identify the cycle, the discussion of season has to do with what's going on within that particular cycle. So now in this case, manufacturers of swimming pools, let's see, if you were selling swimming pools, you would expect for low sales to be in the, I guess, what month, seasons, you would expect low sales. I guess what, fall and winter? And notice how these answers here are exact seasons, but that could be kind of misleading because, as I said, it's not always going to be like a season as we know it. And peak sales generally with swimming pools occur, we'll say spring, summer. Put spring here. And summer right here. So again, we're saying fall, winter, spring, summer, because within the confines of a year, in terms of the cycle, then these words kind of make sense within that context. But if I say cycle, if I identify my cycle again as being weekly or monthly, my discussion of seasonality deals with what's going on inside of that particular cycle, often highlighting high point and the low point within that characteristic. Now I'm going to type seasonal again right here. Okay. And using a year as a benchmark for cyclical, you're going to say typically, in this case, let's say observed in 1 year. Typically. Put this one right here. Often monthly. In this particular diagram here, we're going to say, I guess it's monthly or quarterly. Monthly or quarterly. That's kind of big, but I think you can sort of see that. And so in the diagram here, looks like we have, I guess, 2 years going on, I guess. I don't know. This may not be the best illustration of it, but assuming that this cycle, like from here to here, fall to fall, fall to fall, you know, that's like a cycle, if you want to think about it. Then what they're doing, according to this, is making a discussion of what's happening every quarter. If you have a retirement, I don't know if you guys work and have retirement, generally they send you a statement every quarter, right? But in general, here's the point. Here's the point, and it's hard to kind of, just when you don't have data. The idea is once you kind of identify the overall cycle, you start making comments about what's going on within the cycle. Okay, if this right here were, I don't know, 12 o'clock a.m. to 12 o'clock a.m., then you say something in the middle about the highest point during that time, maybe 5 p.m., then the lowest point. But just notice that a discussion of seasonal has to do with what's going on within your cycle. Essentially, just have a general idea about what these components mean. The final component, as we see here, is called the random component. This is kind of like the wild child of the series, right? So let's say the random component takes into account the random variations in data due to, let's say, unforeseen events. So the random component is also referred to as this, irregular. So if you see random or irregular, it's saying the same thing. Okay. This component is caused by the short term, let's say, unanticipated. Every time we write a word here, it's pretty much going to be the same thing in terms of meaning. Unanticipated, often non-recurring. Often non-recurring. Now, the only way I can describe this, suppose you do a time series like this. Suppose you're doing a time series, you want to do a time series of the ridership of the MTA. I don't know how many of you guys are still in the city, but let's say ridership of MTA, and let's say daily, Monday, Tuesday, Wednesday, Thursday, Friday, or something, I don't know, or January, February, March. And let's say, I don't know what these represent. Let's say it's here on this day, here on this day, here on this day, right? And this actually happened. When I first moved to New York, around 2005, 2006, or something like that, the MTA ended up going on strike. So that meant that the train is totally shut down. no buses, no trains, no nothing. However you had, and I don't have a job anyway, so it didn't matter to me. I wasn't going anywhere. But people who had to go to work, they would carpool. A lot of people wouldn't get home till like 11 at night, and then they had to start out at like 3 o'clock in the morning, right? Well, kind of unanticipated. So when I look at a chart like this, the data would have looked something like this: zero ridership on this day, right? Zero ridership on that day. In other words, in I guess in stat language, I don't know if you guys have heard the term outlier, right? It's like points that are kind of like the wild child of the series. They don't really match with the rest of them, and it can be caused by, oh, I don't know, strikes, coronavirus. It corresponds. So there's, I don't know if you guys realize, but the ship on the subway has gone down drastically since COVID, right? Because people just don't feel safe. They don't do that. So those figures or those data don't really jive with the regular data, how it would be like on a regular ordinary day. And so it could be right here, or it could be way up here. It's just some point that doesn't seem to match, just kind of random, right? All right, so because this component accounts for the random variability, it is unpredictable. Unpredictable. And we cannot attempt to predict its effect. Its effect on the series. All right. And so when you get a hold of these random points, so that's what affects your ability to tell what the trend is, because a lot of those high points, low points can sort of be like a smoke screen, right? It can be really confusing. And so what we have to do is analyze the series by smoothing out. We're going to say smoothing out random fluctuations. There's a mathematical technique we can use to reduce the impact and effect of these random points. It's almost like something called white noise, a whole bunch of noise and this whole bunch of noise. I need to get past the noise so I can figure out what the trend is, upward, downward. And so what we're going to do is use a method called the simple. These really should be 3 blanks. Let's say simple moving. Oh, come on. Simple moving and then average. Simple moving average. What that does mathematically is going to allow us to kind of look at the time series and get rid of or smooth out the effects of these wild childs, these random irregular effects. Any questions so far? So those are the 4 components. You need to know what they are just in general and kind of what they do. Now, let's go to the next page. We're going to say the simple moving averages method. So I don't have to be blank, so I'm just going to type simple moving nice simple moving average method. Uses the average of the most recent end data values as the forecast for the next period, or as a starting point for the next series period. So mathematically, look at that. We know what average means. Average means just take the number of data points you have and divide by however many you have. If you have 3 points, you add up all 3 data points and divide by 3. If you have 5, you add up all 5 and divide by 5. So you have to establish a size of your window. Okay. The term moving, so let's put moving right here. I'm going to put it in quotes. The term moving indicates that as you get an average, you're going to move the window of the same size. Okay, and we're going to do a problem. Let's go say, hence, a new average is computed. A new average is computed. What we're going to do is we're going to go through this technique of smoothing out the data on the next page and see how this algorithm works. So you're going to need some notebook paper because we're going to actually do a problem regarding this. So this is page 7. I'm going to have to go back and forth to the board when I do this here, but just take a look at that data. So I know it's a time series because of this right here. All the information right here has something to do with time, and the data is successive, year after year after year after year after year. Okay, now this is the real data here in terms of revenue, and it's giving millions of dollars, but we're just going to work with the data. So this is where the action is going to go on. This is just telling what the time is. This could also say January, February, March, April. So I'm not going to do any math on these. I'm just going to do math on these right here. That's step 1. Construct the basic plot having the blank component on the x-axis. So we're going to say time component. Time component on the y-axis. So if you want to get out a sheet of paper and do this, I'm going to do this as well here. And I turned off my camera on the other page because I just don't know if I can sort of do both of these together. So just let me know if there's going to be a problem. So we have regular.
Professor, that's
Yeah.
gonna be an issue because the circle is small, so we can't really see clearly what you're writing on the board, unless there's a way to make the circle bigger.
Let's see. Oops. What did that just do? Okay. Let's see. Oh, okay. How about that? Is that bigger?
Yeah, it's bigger.
Oh, how about that? I see that.
Yes.
Right. All kind of stuff with Loom. Have you guys used Loom before? It's a really, really good program. Okay, so I'll deal with it here, and then I can go back to time component down here. So what's time? So what's the first thing that's going to go right in the chart? What's the first? So this has to be in years. What's the first year that you see? 19 what?
19.
1982.
So we're gonna put all those. Tell me where does it stop, so I know where it's.
1990.
Okay. 86, 87, 88, 89, 9. All right, so that's the time component, year. Now, what we need to do is just type the corresponding put the corresponding values on here. Now, what's the, look at all of the data. What is the smallest year that we have? What's the smallest year? Because I want to look at the range. What is that? 1310, I guess. And the highest is 1937. So it's just going to help me figure out where to put these. So I'm going to go in. I'm going to start at 1300 and just go to maybe 1900. And I'm going to go up in terms of hundreds. So the largest and the smallest value is going to help me figure out kind of where to stop. It's not graph paper, so it's not drawn to scale, so don't worry about that. All right. Now just literally go through and put a dot that corresponds with the data. So 1982 is 1588. There's roughly around here. Oh, I don't know. In 1558. Just kind of guesstimate and just go ahead and finish that chart. 1753. 1408. 1310. 1424. 1677. 1937. That's way past here. And then 1685. Okay, fair enough. And then just connect the dots successively, one after the other. So literally just all right. It doesn't have to be pretty. I mean, you know. But that's the first step. This right here is a time series. That's a time series. Very simple. No frills, no nothing. Just putting the dots and connect it. So, can you do that? I mean, that's, all right. So now suppose I had to ask you what the trend is. What would your response be? This is the regular data. How would you respond based on what we talked about earlier? What is the trend of this time series? Anybody want to guess? What is the trend? What would you say? Would you say it's an overall downward trend? It's really hard. Because, I could maybe see, I don't know. This point here is kind of throwing it off a little bit. I don't know if that's pushing everything up there or if it's, so in other words, what happens when the trend is not obvious? Then we use the moving average, simple moving average technique, because when you finish with that technique, it's like putting a magnifying glass up to figure out what the trend is. Okay, so that's step one, doing this right here. Let's go back to the handout. All right, step one, step two. So make sure you keep that diagram there because we're going to need that in a. So now step two, determine how many observations. How many observations will be considered in the moving average window for the problem. In our problem, we're going to use 3 observations. I would have to tell you what size the observations will be, and without going to it in this course, but at least right now, I'm always going to give you an odd number. Okay, so here's a 3, it may be a 5 or whatever. So I'm going to denote this by this. There's 3 observations. I'm going to call it SMA parentheses 3. That's the notation we're going to use. That lets you know it's a simple moving average with a window of size 3. I'm always going to tell you what size. Now, why is that important? This next step here says compute moving averages based on the determination in step. All right. So here's what we have. You're going to have to look at the original data. Go to the original data. Look at these 3 points right here. 1, 2, 3. Okay, this is, I'm going to write this right here. I hope this is going to make, as a matter of fact, I'm going to do it this way because it's going to take too long to do it. So on your paper where it says A, you're going to write this. This point here, is that, what's that first point? 1558. Is that 1558? What are the first 3 points? 1558. What's this one? 15. What's this point right here?
The first one was 1588. The second
Oh.
one is 1558.
Okay. 1588 plus 1558 plus what's this third one, right?
1753.
Okay. 1753 in parentheses, and then all of that divided by 3. That's what you're going to write in that first blank where it says A. Write this right here. This plus this divided by 3. And I'm running out of room here, but beside it, it says equal. And figure out what that value is. We're taking the average where the window is size 3. Because I'm only looking at the first 3 points. I'm taking this point plus this point plus this point. It's the 3. Adding them together and finding that average. Let me know what you guys get when you find this average. Is it like 16 something?
1633, I got.
1633. Normally we'll take 1 decimal. What's 1 decimal after this? Is there any decimal left? Or just 1633?
I just got flat 1633. I don't know what anybody else got though.
1633. Now watch this. This is crucial. Now for B on your paper, watch what I do. Here's the window size 1, 2, 3. I'm going to take the same size window as 3 and shift it down 1 unit. See, it was right here, those first 3 points. Now shift it down 1 unit so that now I'm looking at this point, and this point. So in B, you're going to write 1558 plus 1753. Now what's this point right here? 14 something? 1410 or something? I don't have my, is it 10?
1408.
1408, okay. And now divide that by guess what? 3. See, in other words, the average is moving. The average is moving. But it's the same size window. It's still a window size 3, right? Now figure out what that is. So continue in that pattern. First, get answer. The next 3, get that answer. The next 3, get that answer. And keep going all the way to the end. And we'll talk about what your answers are once you sort of do that. The last 3 are going to be these. 3 here are going to be that last blank. Just move them a little bit at a time. 1 unit at a time, but keep the same size window. Keep the same size window. Keep the same size window.
Professor, can you repeat that? You said to skip over 1? Because I don't know, you keep on lagging. I don't know if it's just me or.
So you're going to take the same size window, 1, 2, 3. Get the first answer. The next answer for B is you're going to take the same size window. Then you're going to take the same size window and shift it over 1 unit. Now you look at those 3 points. Now shift it over again, 1 unit. So you're always going to be saying this plus this divided by 3. But you're only going to use it with 1 unit at a time. 1 unit at a time. 1 unit at a time. 1 unit at a time, right? So you're going to be dividing by 3, but each time you move that window, you're going to be adding another value to it on the front end and dropping the other value on the other end. Okay? So the first time you're going to look at these, then you're going to move it 1, you're going to look at these, right? But the window is always going to be the same. The size is going to be the same. So for C, it's looking like it's going to be 1753 plus 1408 plus 8 I guess this is 13 something. If you can see the handout here, because here's the data. So the first 3 points, I'm looking at these, divided by 3. I'm going to shift. Next, I'm going to look at these 3 points. Get that divided by 3. And I want to look at these 3 points. You see how the window size is still 3? I'm just shifting the window down 1 unit every time to get the new average. When it's all said and done, I'm going to look at these 3 points. All right. And I don't really care. You take 1 decimal, 2 decimals. You know, it probably at most 1, because when you plot it, you're not going to really be able to plot decimals anyway. So, okay, so let's see. I'm going to have to rely on, and the good part about this, just use your calculator. I mean, this is not like super hefty Excel stuff. As long as you know how to punch in your calculator and say divided by this, divided by that, you know, this should not be problematic. I'm going to go really quickly through these answers that you got. Okay, so let's see. For A, that was 1633. You got to help me out. What'd you get for B? Real quick. What you guys get?
1573.
1573. Okay.
Yeah.
C. What you guys get for C? And if you guys get something different, you're gonna have to chime. What's C?
1490.3.
Okay, 1490. I'm just going to round it out. 1490. D. What did we get?
1380.
1380. Okay. E. You gotta do E yet?
1470.3.
Okay. 3. And the last two, what did we get? Uh,
1679.
1679 or 15? Is that right? 1679? And then the last one is what? And those should be those last.
1766.
1766. If everybody right quick. The reason I kind of do time series last is because it requires the least amount of brain power to get these answers right here. Right? Everybody check these and make sure you have these right here. I'm not too much worried about the decimal. That's not a big deal because you can't really apply decimals anyway. Now, if you have a different color, like a different color pen, grab it. If not, see, we're going to put this SMA on top of this right here. So if you don't have a different color pencil or pen, just use the same pencil, but then just end up doing a dotted line so we can sort of distinguish. I'm going to use a different color. Now, look at the 1633 right here. I need to put this somewhere on this time series. Yes. You would think it would go right here, 1982, right? But it's not. You're going to have to get used to it. This 1633, visualize this with me, has to be plotted in the middle of the time window, or the average window, in the middle position. What size window do we have? 3. 1, 2, 3. So 1633, when I plot it, is going to be plotted in the center of the size window. The center of this size window, which is 3, is at this year right here, 1983. So essentially what's going to happen is I'm going to plot these values right here, but I'm going to start plotting in the middle so that when I get finished plotting, I'm going to end up with a point starting right here, and then when it finishes, it's going to end right here in 1989. So there will be no plot the first point or the last point. Okay, so follow me here. 1633 then is going to be plotted here. 1633 right there. Because this represents the middle of the 1, 2, 3. Boom. Suppose I have an SMA 5. That means that you would have added the first 5 values here and divided by 5. When I plot this point, it would be in the middle of that 1, 2, 3, 4, 5 window, which would be at the third slot. So let's don't worry about the SMA 5. The SMA 3 just simply says, I'm going to plot this in the middle of the window, and all of the values here will just follow suit. I just plot in the rest of the values there, because when I plot this 1573, it's going to be in the middle of the second window, which is 1, 2, 3, which is right here. But don't worry about all that. Once you figure out where the first one goes, just plot the rest of the values like right beside it in succession. So here's 1573, 1490. So the values that I'm plotting now are all of these right here that I did divided by 3, divided by 3, divided by 3. 1380, 1470. And you're just going to have to estimate. We don't have graph paper, so 1679 and 1766. Somewhere there. Notice there is no plot here or no plot there. So when I get finished plotting this SMA3, it's almost like plotting snugly within the original series, right? It's sort of snugly. And what does it allow me to do? Well, go ahead and plot those, connect those dots. I have a different color, so it'll be obvious. If you don't have a different color, just do a dotted line. Be careful, just make sure you go kind of in order. See that? See that? And what this method is supposed to do, it's supposed to give you a better idea of what the trend is. Whereas you may have been confused at the purple in terms of what the trend is, this process is supposed to be smoothing out the random irregular parts. See that? Now, I don't know if you can really tell what the trend is by using the red. I would guess upward trend, right? But that's the idea. And so I guess the last thing you could do, you guys know what a legend is? Just, we'll say something like this is like the original series. And then this red, I'll just say is SMA3 or something like that. Just so you can have an idea about this stuff represents. Does this make sense? I mean, just in general, in terms of the methodology, right? I guess the hardest part, if you want to call it hardest part, is figuring out what these are. But as long as you know what the size of the window is, which I give you, it really shouldn't be a big deal, because you're just taking those first points, in this case, divided by 3, you're just shifting, 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 shifting. But notice the size of the window never changed. It was always a size of 3. Okay? Let's go back to the form. Step 4, okay, so we did all this. Step 4 simply says overlay the moving averages on the same axes. In other words, just plot the new series on top of the old one and just make sure you have different colors or whatever. Okay, let's summarize this. Let's summarize this. A time series is comprised of how many components? How many did we say? Is it 3? So this is a summary slide. We'll say the trend on it is overall persistent. So this is trend. Up and down movements, I'm going to call that cyclical. Within the cyclical, we have that seasonal. Seasonal there. The random component refers to blah, blah. Okay, so that's random already. And then in this last one here, just say the simple moving average. That's a technique that we use to smooth out the rough edges as it's a simple moving, and in the last blank put average. Simple moving average.
Could you go up for a second? I think I missed.
Okay, all right. Simple moving average there. There you go. So again, we're gonna have to make sure. So your quiz is next week. It could come from like just this basic stuff, right? It could come from stuff we did last week that we kind of did the original period today, talking about adjusted R squared, kind of reading those results.